How does superheated steam work in the Rankine cycle? Imagine a steam engine running smoothly, powering a city's electricity. Now think about how the steam inside it is prepared to do the most work possible. That's where superheated steam comes into play. In the Rankine cycle, superheated steam is a key player in making power plants more efficient. The cycle has 4 main steps: pumping water to high pressure, boiling it into saturated steam, expanding the steam in a turbine to produce work, and then condensing it back into water. Superheated steam is created after water is turned into saturated steam in the boiler. It then passes through a superheater, which is a special heat exchanger. The superheater heats the saturated steam further without increasing its pressure. This process makes the steam hotter than its boiling point at that pressure, but it remains dry, with no water droplets. Having superheated steam in the cycle offers several benefits. First, it raises the maximum temperature of the cycle. Higher temperatures mean the cycle can extract more heat, which boosts efficiency. Second, superheated steam stays dry when expanding in the turbine. If saturated steam condenses into water droplets during expansion, it can damage the turbine blades and lower performance. Superheating prevents this by keeping the steam in vapor form. Another advantage is that superheated steam carries more energy, or enthalpy, at the same pressure. When it expands in the turbine, it produces more work or power. This means the power plant can generate more electricity with the same amount of fuel. Additionally, superheating allows plants to operate at higher pressures and temperatures. These higher conditions help achieve efficiencies that can go over 40%, which is a big step forward in power plant design. In practical terms, the cycle begins with water being pumped into the boiler at high pressure. Inside, it turns into saturated steam. The steam then moves through the superheater, where it gets heated further into superheated steam. This superheated steam expands through the turbine, doing work to turn the generator. Afterward, the steam cools down, condenses into water, and the cycle starts again. Superheated steam is essential for modern power plants that burn coal, natural gas, or use nuclear energy. It helps improve efficiency, protects turbine blades, and increases power output. This way, power plants can produce more electricity with less fuel, making the whole process cleaner and more cost-effective.